Welcome to this release of Design Fusion's Solid Edge blog. In this blog, we'll look at an example of creating and animating a mechanical chain. Solid Edge provides advanced options in the Assembly Pattern Along Curve command to simplify the creation of mechanical chains. Furthermore, using these advanced options in conjunction with a variable table motor, users can animate their creation. Let's first have a quick look at these advanced options in the Pattern Along Curve command. The Pattern Along Curve command includes the chord length pattern type option, which is primarily used to create chain or chain-like components. This option also includes the pattern alignment option of Follow Curve Chord. This orients the parent to align with the curve chord. With this option, you will be able to wrap a chain link or 2-pin track, such as the one shown on the slide, around a curve. It's important to note that when patterning a chain link or an object that has 2 holes around a curve using the chord length option, you need to always select the back hole as the start point of the pattern. If the back hole is not the pattern start point, then the part will not follow the curve properly. This has to do with the chord length adjusting the part to the next element on the curve. The chord length pattern supports a count, spacing, and skip option. The count value is the total number of occurrences that will be placed for the selected curve length, including the parent. The spacing value is specified as the chord length between 2 points. The skip value only applies to patterns where the chord length pattern type is specified. The skip count option is used when more than one parent is to be patterned. This allows multiple patterns in sequence along the curve chord. The skip value is specified as a whole number, where the value of 0 means all instances as specified in count are shown starting with the parent. For a value of 1, alternate instances are created with the parent as the first instance. For a value of 2, every third instant is created with the parent as the first instance. The value can increment up to 2 less than the total value of the count. Let's have a look at this in Solid Edge. To demonstrate the creation and animation of a mechanical chain, I've opened this assembly file. Here I've already created a layout sketch representing the path of the chain. I'll start to assemble the chain by bringing in an existing link assembly from the parts library. As this is the first component, the link is grounded. I'll select the grounded relationship and delete it. Next, I'll use the assembly relationships to position the link component. I first apply a mate relationship between the front face of the component and the sketch plane. Notice that the component now lies on the sketch plane. I'll then create a path relationship between the link and the layout sketch. For this path relationship, I want to use a fixed offset. For the follower, I'll select the axis of the first pin. For the edge chain, I'll select the layout sketch and accept it. At this point, I want to set a fixed offset value of 50 millimeters from the origin point. To define the origin point, I select the origin point option and select a point on the sketch. I can use the flip button if the link is placed on the opposite side from my desired side. I'll accept this and exit the command. Notice that the deleted ground relationship has been replaced with the mate and path relationships. To fully position the link assembly, I'll add one more path relationship. This time the path relationship will use a floating offset. For the follower, I'll select the opposite pin. For the edge chain, I'll select the sketch again and accept it. I now have a fully positioned link subassembly. Next, I'll locate and insert the coupling assembly. I'll then use the mate relationship to position this so that the inner face mates with the sketch plane. If the orientation is incorrect, I can use the flip button to correct it. I'll then use the axial align relationship to attach the coupling to the link. To fully position this, I'll use the path relationship to align the back pin of the coupling to follow the layout sketch as I did with the link. Once I've accepted the path relationship, I can see that I have the link and coupling fully positioned on the layout sketch. With the building blocks of my chain in place, I can now create a pattern to create the chain. I'll first hide the coupling to pattern the link. Here I'll use the pattern along curve command. I'll start by selecting the link as my component to pattern. I'll pattern this along the layout sketch curve, with the anchor point being this point. I'll use the project point to curve option, which specifies the offset distance from the selected key point by projecting a point from an element in the assembly. Next, I will use the advanced options that I discussed in the slides. Notice that I am using the chord length pattern type. I'll enter in the count and spacing values and apply a skip value of 1. I'll click Next and set the occurrence orientation to the Follow Curve Chord option. I'll click Preview and Finish. Notice the resulting pattern. Depending on your settings, you may see numerous coordinate systems throughout the pattern. These can be turned off if they appear. Next, I'll show the coupling assembly, and I'll hide the link component and pattern. I'll then pattern this component using the same steps I used with the link. Once I've completed the pattern, I'll turn on the entire assembly. Here I've created the mechanical chain. Next, I'll use that 50mm path relationship offset in conjunction with the variable table motor to animate the mechanical chain. I first define the variable table motor using the variable table motor command. The variable I'll use is the 50mm offset value. I then set the desired speed and limit. Once the variable table motor is created, I can use the simulate motor command to animate the chain. I'll assign the variable table 1 to the motors in animation column and click OK. I fit the view and hit play to view the animation. As you have seen, this uses advanced processes in Solid Edge, which along with many other advanced processes are taught in the Advanced Assembly course. Want to learn more? Please sign up to our customer portal at the website listed here, where you have access to knowledge-based articles, tips and tricks, how-to articles, and much more. If you need additional support, contact our support team at support@designfusion.com or call us at 1-877-215-1883.